So first of all, we look at what is chromatography. So chromatography is a separation technique used to isolate components of a mixture based on their movement through stationary and mobile phases. The stationary phases being the water, as we can see here, it's a solution, actually a chemical solutions, and the mobile phases being the paper, as shown in the photo. It is widely used in various of industry, for example, food testing, pharmaceuticals, and environmental monitoring. The purpose remains the same, which is to identify, purify, and quantify substances. But the general principle of chromatography remains the same regardless of the differences. For example, the components must move at different rates depending on their affinity for the stationary and mobile phases.
And now I'm going to present to you the classifications for this chapter for basic chromatography. We have separation mechanism. We have four category of them, which is partition, absorption, ion exchange, and size exclusion. For chromatographic method, we have two, which is the planar method and column method. And last but not least, for planar techniques, we have two of them, which is paper chromatography or thin layer chromatography. In partition, chromatography separation based on solubility differences between two liquid phases. And for absorption, chromatography components adhere differently to the surface of the stationary phase. For ion exchange, the chromatography separation is based on the ionic charge interactions, while for size exclusion, chromatography molecules separated by size using porous stationary materials. As what I just said just now, there are two methods of chromatography, which is planar chromatography and column chromatography. For planar chromatography, the stationary phase is flat, like paper or thin layer, like that. For example, paper chromatography, we have thin layer chromatography. Meanwhile, for column chromatography, the stationary phase packed in column in mobile phase flows through, includes gas chromatography and supercritical fluid chromatography as advanced column techniques. How do we use paper chromatography? How do we do the chromatography? So this is the application. For identify components in food dyes, for example, the method is apply dye samples on chromatography paper. Place paper in solvent, allow capillary action, and then you observe separated colors bands on it. Based on partition mechanism, dyes dissolve differently in stationary and mobile phases, as you can see in the diagram below.
So in order to calculate the retention time in chromatography, we need to look at this formula. First of all, the distance traveled by solvent, which is labeled as B, and also on the chromatography paper shown on the photo or the slides, is on the below, whereas the distance traveled by solute, which is labeled as A, is on the above. So distance traveled by solute and solvent respectively. So in order to understand how to use retention time formula properly, we need to do some examples. So as you can see, the table clearly displayed the food dyes, the number of components, and the colors observed. Whereas it is also showing the RF value. So how do we calculate the RF value? This is an example of the calculations of one of the RF values, specifically the 0.45, the first one being observed or recorded in the table earlier. So as you can see, the RF values, the distance traveled by the solvent, is below, whereas distance traveled by substances is on top. So it is basically B over A, as shown earlier.
All right, for the industrial and analytical applications, we have four fields that use this. For the first one, we have the pharmaceuticals, which use in purification and impurity detections. The second one, we have the environmental testing, which use in identifying pollutants in water and soil. The third one, we have the food industry, which use in quality control and additive and preservative. For forensics, we have the detection of drugs, inks, and toxins. The last one, we have the research, which used in biochemical and molecular studies. Alright, for chromatography in daily life, we have four fields that involve in chromatography in their fields. For the first one, we have the medical labs, which is used in the blood and urine analysis. The second one, we have the perfume industry, which used in separation of aromatic compounds. The third one, we have the beverage testing, which is ensure products consistency. And the last one in education, which we use in demonstration of separation principles in chemistry labs.
In conclusion, chromatography is an important technique which allowed many industry to thrive and improve the life of many humans. Thus, understanding how it works is essential, especially for science students.